So welcome back. Again, we're going to work with determining the slope of a line. And what we're going to be given is a linear equation, and we're going to determine the slope of a linear equation by looking at the equation. One of the things we pick up on is if a linear equation is solved for y, it's in a special form which we call the slope-intercept form. And what we pick up on the slope-intercept form is the m, in other words, the coefficient in front of x is actually going to represent the slope. And this b is actually going to be what we call the y-intercept, where the line crosses the y-axis. So if I look at this example, so determine the slope of the linear equation. Notice this equation is solved for y, just like this equation is solved for y. What this is telling me then is this coefficient, the number in front of the x, is actually my slope. So my slope is negative 2/3, and if I wanted to know my y-intercept would have been 1. Okay? Let's just verify this to verify that indeed that negative 2/3 is the slope. So we know that to find the slope, if I know 2 points, I can use the slope formula to determine the rise and the run. So again, when it's solved for y, it's always easy to pick 0 for x. So I'm going to substitute 0 in for x, so y is going to equal negative 2/3 times 0, adding that 1. We know negative 2/3 times 0 is going to be 0. 0 plus 1 is going to give me 1. So 0, 1. And if I graph that on the graph, 0, 1. Notice that point is on the y-axis, so it's going to be our y-intercept. And take note of what our constant was, this b. This b indeed was 1. So that is kind of playing out the way we said it was going to play out. Now, the next value I pick for x, since I have a fraction here, I want to pick a value for x that can be divided by 3. So 3 would be a good choice. So I'm going to have y equals then negative 2/3 times 3, and add that 1 there. Again, these 3's would divide out. Y is going to equal a negative 2 plus 1, and therefore I would end up with a negative 1. So when x is 3, y corresponded to be a negative 1. Okay? So there's my 2 points. So 3, negative 1 would be located at this spot. So now I could graph the equation. And remember, these linear equations take on the look of a line. So, looking at our line, notice that as I move from left to right, it's going in a decreasing direction, so it should have a negative slope. If we use our rise and run, so starting from one of the points, if I rise up from negative 1, I got to rise up 1, 2, so I got to go up 2. And I got to run over to the left 3, so it's a negative 3. So what I'm picking up on is my slope is a 2 over a negative 3, which we can also write simply as negative 2/3. And so that is playing out to be the slope that we were figuring it should be. We also have these two ordered pairs. So if I want to find the slope, I've got 0.1 and 0.2. And we know the slope formula is y2 minus y1. So I have a negative 1 minus 1. And I have x2 minus x1, 3 minus 0. So my slope is going to be a negative 1 and a negative 1 makes that a negative 2. 3 minus 0 would be 3. So that does give me a negative 2/3. So it's playing out. So to find the slope of a line, we could graph it, use our rise slope run to identify the slope. We also could find two ordered pairs, use the slope formula But now what we're picking up on is there's this slope-intercept form. So if I'm in this form, y equals negative 2/3 x plus 1, notice how that number there is actually my slope. And I wouldn't have to do any of this math, actually. I could just go straight to the chase. If they want to know the slope, it's just that number in front of that x. And if the equation looks like this. So let's see where this takes us. Stay tuned for more.